Hi, my name is David Rawson. I'm a practice lead at ClearPoint, and I'm excited to talk to you today about a new text about my area of specialization, which is mobile app development. So first we're going to explain what the text is and who it's by, and then we're going to explore some of the unique challenges of mobile development, why it's different from front-end web development and back-end development. And then we're going to look at some of the ways you can respond to those challenges, different technologies and different approaches for your mobile app. So building mobile apps at scale, 39 engineering challenges, was published in 2021. And just like for back-end development, how we have Building Microservices by Sam Newman, I think this should be an authoritative text for mobile apps. So why are mobile apps so tricky? Well, first problem we encounter is that mobile apps mistakes are hard to revert. What do I mean? Well, let's assume we make a mistake with our web app and we're causing the user to see a 404 not found. We simply redeploy our web app and the user refreshes the page, the problem is solved. Things are not so simple for a mobile app. First, we have to make the fix. Then we have to submit the binary containing the fix to the Apple App Store and the Google Play Store for review. Then the user actually has to update the app to receive the latest binary, and they're not always willing to do that. In practicality, what that means is you have a long tail of old app versions. So in this chart, on the y-axis, we have adoption rate, adoption percentage of our app, and on the x-axis, we have time over the month of October. So version 1 in blue and version 2 in red are just sitting at very low adoption, 4 or 5%. These represent old versions of the app where users have got no update path. So they're on an old version of their phone, or old phone, and your new binary uses APIs that their phone can't consume. Version 3 in yellow, you might think of that as the latest version of the app for the month of October. And you can see it's sitting about 80% adoption. On the 15th of October, we're going to release our new app version in green, version 4. And you can see it's going to slowly ramp up over a week just to make sure there's no problems. And while it's ramping up, version 3 in yellow is slowly ramping down. But that ramping down is asymptotal. It's never going to completely disappear. And that's what we mean by a long tail. And a really nice analogy is once you've fired a bullet from a gun, you can't retrieve that. In the same way, once you've released your mobile app binary, it has to keep working for a long period of time and keep working through updates in your API and SSL certificates expiry and all the crazy events you might experience in your business. So that's one reason why mobile apps are so tricky. Another reason is state management. So in a mobile app, you have events like, say, ordering a taxi. Those events will trigger some internal state change, like a pickup mode, and that state change will be reflected in the UI. So for example, it'll be showing you your current location on the map and the location of the taxi that's coming to pick you up. Now you might think, okay, well, state management is a solved problem. We have, in the web, we have solutions like React and Redux, which handle that for us. I'd like to propose that mobile apps are state squared. So here's a typical interaction with a mobile device. I'm out planting trees on my friend's farm, and I think it's a good photo opportunity. I hand the phone to my friend and ask him to take a photo. So you can see all the events and all the state changes here. First, there's an event to turn on the power, which triggers a state change, from the app being sleeping and from the phone being sleeping and conserving resources to being active. And then there's a state change to the home screen. And finally, a state change to access the camera. Even while the camera is active, there's all sorts of events coming in from the gyroscope and these events from the user actually clicking the shutter. So if you think of it philosophically, the mobile app is being carried with you and it encounters the events and state of the real world. And another way to think about it is the mobile device is at its heart a phone. It's a device designed to respond to events like an incoming call. Given that we have these problems of mistakes being hard to revert and state management, how do we respond to them? So one solution is what Orosz calls cross-platform app development. Now this is where you have one code base that completely covers both platforms, and it covers both layers of the app, so the UI and the business logic. In Flutter, this would be a single code base written in Dart. In React Native, it would be a code base written in JavaScript, and in Xamarin, a code base in C#. Now, cross-platform app development has some advantages and disadvantages. Firstly, there's a cost. You have one engineer who can cover both platforms versus two separate engineers. You also have reusability that's maximized because you're covering all layers of the app. There's a novelty factor where you have frameworks which are very popular and generating a lot of hype, like Flutter. And one common problem you have with native apps is the functionality drifts between iOS and Android. So the engineers will understand the spec in two different ways, and the functionality will differ between platforms. You're not going to have that if you have one single code base. The last advantage is what Orosz calls assuming it's easy to hire. So I think he's talking about assuming that you can turn web devs into mobile devs. Now, there are some disadvantages of pursuing a cross-platform app development strategy. And the first is it's one more thing that can go wrong. So, for instance, Flutter, you have the Android platform, and then on top of that, you have the abstraction that Flutter provides, and then finally, you have your own code. So when something goes wrong, is it a problem in the Android platform itself? Is it a problem in the Flutter? Or is it a problem in your code? It's one more complexity. Native code could still be needed, especially if you are interacting with the hardware, the camera, the Bluetooth, and so on. Cross-platform frameworks can be behind. So let's assume that Apple puts out some new UI component. That might take months to actually arrive in the realm of React Native. Then we have this problem that you experience a lot with different engineering decisions. You'll have a vocal group of advocates who start the journey, and these engineers may or may not be around 1 or 2 years around, and other engineers may have to pick up the pieces. And the last point from building mobile apps at scale is mobile engineers will always favor native. So if you want an engineer who is really, really familiar with iOS and is really enthusiastic about making your app look like it's part of the phone, then that is much more likely to be an iOS native engineer than a Flutter engineer or a React native engineer. So looking at Flutter itself, according to Orosz, this is the most mature cross-platform app development framework in 2021, and it's used at companies like BMW, eBay Motors, and Nubank. React Native had very strong momentum in 2016. However, it was adopted and then famously abandoned by Airbnb. Xamarin is, according to Orosz, a great way for .NET shops to bootstrap their mobile app, and it's used in production at places like DraftKings, at Philips, and at BBVA, which is a Spanish bank. That was cross-platform app development. An alternative here is cross-platform feature development. This is where you have a common core of your code and you have uncommon platform-specific code. There's different ways you can accomplish this. One way is to use shared libraries written in C++, which Android can consume because Android has the JNI, the Java native interfaces. It's a particularly good option if you want performance. Ribs from Uber is a cross-platform architecture where you standardize terms and you use code generation and tooling to enforce that between the two platforms. J2 Objective-C is a framework where you write code in Java and it's transpiled to Objective-C. And it's a bit of an older tool, but it is used internally at Google. And lastly, we have Kotlin Multi-Platform Mobile. We'll talk about that shortly. So the Kotlin compiler can very famously target the JVM and emit JVM bytecode, but there are other targets. And Kotlin Multi-Platform Mobile leverages this to allow you to have a shared code base that will be common across iOS and Android. It's in beta as of October 2022, and it's used at Netflix, but not in the flagship Netflix app. at Square and at VMware. So some advantages is Kotlin is a modern expressive language, which is very similar to Swift, and it's an ideal choice for native mobile devs. Not only that, it encourages you to use native UI components, and especially newer native UI APIs, such as Jetpack Compose and Swift UI. And it also sees a lot of investment from JetBrains and Google. Some disadvantages are that it's still in beta and it's lacking in some supported libraries. Last approach we're going to talk about is PWA and Web Apps. PWA stands for Progressive Web App. It's using newer web APIs, HTML5 and so on, to build a native-like experience. Now, Orosz says it's unlikely to supplant native technology, but it's a good tech to keep your eye on. Another approach is to actually embed web screens inside an app. So you can make the app essentially a shell and then serve web content embedded in the app. Doing that is not free. It's hard to implement an offline mode, and you can end up in an uncanny valley where you have components that don't look native and don't quite look like web components. And you can also run into performance issues because JavaScript that's optimized for a web browser may not be optimized for a mobile client. I really hope you can go and buy the book and learn all the details about all these different approaches, and even subscribe to The Pragmatic Engineer. It's a great blog with lots of amazing insights from industry insiders. Thanks for listening. We'd love to help you with your mobile apps here at ClearPoint.